Hello, everyone, and welcome to the data structures class. So we're going to go ahead and get started in just a couple of minutes. Um, so we'd like to go ahead and hear from you if you have any questions. And so we'll just wait for folks to go ahead and start showing up here. So we'll get back to one another in about a minute. All right, so let's go ahead and see what the state of things are. We are hoping that more folks actually will go ahead and join us. So let's go ahead and give ourselves yet another minute, and we'll get started with all this. All right. So at this point, we can go ahead and begin our conversation on what we were talking about before, which is deletion. Now, I guess before we go ahead and talk about that, if there's anything that anyone wants to go ahead and ask, share with us, by all means, go for it. So anyone here yet? Yes, we have a few people. We have just a couple of people. So of course, being that all of this is being recorded, it's all good. It'll be in the recordings, and so people can go ahead and watch this stuff at some future point. So let's go ahead and get started with this. Now, as you all remember, the conversation that we were having is when you're looking at a bunch of nodes. So let's just say we have 7, we have 5, we have 3, we have 12, we have then 9, for example, and let's say we have 8, and let's say that we have another one, which is 13. And actually, let's go ahead and make this 11. So we indicated that for deletion, we'd like to go ahead and just keep a few things in mind. And so let's go ahead and find out what is going on here. So at this point, there are some questions that are being asked with regards to certain due dates. We'll go ahead and deal with those a little later. So let's not worry about those for the time being. Let's go ahead and just focus on the task at hand, which is how do you actually go ahead and delete from this linked list. So we said that there are really all these considerations that we need to go ahead and make, which is what happens when you want to go ahead and delete one child. this child that actually has, or this leaf node that actually has no children. And we said it's as simple as actually just getting rid of this node and making sure that the left-hand side of that node actually is pointing to nothing. So we need to go ahead and make sure that we make that null. What happens if you want to go ahead and delete a node that has one child, such as 5? Well, in that case, what we need to do is we need to go ahead and make sure that there's a connection between that 7 and the 3. Now, of course, there could be other things that could be connected to this. So we could actually have a 4 here. We could actually have a 2 here. But that doesn't really matter. As far as the 5 is concerned, there is only one child that it has. And so when we connect the 3 to the 7, everything would still be intact. Then the other piece is, well, what happens if you want to go ahead and get rid of 7 itself? Well, if you want to go ahead and get rid of 7, this requires a bit more complication. And we said that the way that you actually go ahead and do this is by actually going to your right first, and then by going all the way to your left, and you repeat this going to the left as many times as you need until you get to the leftist node in the right subtree. And then what you're going to go ahead and do in this case is you're going to go ahead and take that 9 that we have, and you will take just the value itself, and you will go ahead and replace that with 9. And then once you're done with that, at this point, you need to go ahead and issue another delete function. And you need to go ahead and issue the delete function as if this is your entire subtree. And starting from this point on, let's go ahead and delete 9. Well, when you delete 9 at this point, it becomes like another problem that you're facing, which is how do you go ahead and delete a node that in this case has one child? Well, we already know the solution for that. You're going to go ahead and just connect this 11 to that 12. So that is a problem, like a brand new problem that you want to go ahead and solve at this level. There's a question that's being asked. The assignment is not specified, but do you want to go ahead and use a particular method to insert the individual binary nodes? And the answer is no. You could actually go ahead and use either one. You could use the recursive algorithm, or you could actually just use plain iteration. All of those are actually available to you. Now, we indicated that when you want to go ahead and do a delete, what is happening is you need to go ahead and make certain considerations. First of all, you need to go ahead and identify the node that you want to go ahead and delete, which means that there's a searching that's involved. So you go ahead and start at a certain point and you go down. So the search routine that we came up with, you need to go ahead and incorporate that. And so you search and you may not find, or you may search and you may find. Now, if you find, there's the scenario in which you have no children, you have the one child, or you have the 2 children. So let's go ahead and find out what is going on. There is the consideration that there's nothing. So did not find, as we indicated. And so the way that this works is if you go ahead and just say, you know what, if return a null. So nothing was found. The leaf that you're on, that you're processing, okay. So we should be, so sorry about that. It looks like just this went off the line. And so we are now back online again. So key is less than leaf key. So let's just say that we want to go ahead and get rid of the 5 less than 9. Yes, the answer. And we need to go ahead and go to our left. And we need to go ahead and make sure that we pass in the key that we are searching for as well. And then else if, just watch 10 seconds before the live, so there's no delay. Okay, so if key is greater than leaf key, then we said that you need to go ahead and go to the right. Now, when you get to the else, this means that we've actually found what we're looking for. Because you see, there's the scenario in which we didn't find. There's a scenario in which we needed to move to the left. We needed to go ahead and move to the right. But at some point, we will find it. And so this is where we land. And when we land here, then this means that we need to go ahead and deal with the case in which we have no children. And we have no children if leaf left is null and leaf right also equals to null. So if both of them are null, this means that we're looking at a leaf node. So like for example, if let's just say we want to go ahead and get rid of 2, notice there is no left, there is no right, so there's only one item that we're dealing with. Now, there's also the possibility that we may have 2 children. And if we have 2 children, this means that if there is a leaf left and there is a leaf right. So this means that we actually have both of them. And so we're going to go ahead and do something else. And then we have this else. Now, so if there is no children, if there are 2 children, then this else means that there's only 1 child. And so for the 1 child, we'll need to go ahead and find out which one it is that we do have. So if it's the left child, then we need to go ahead and send back the left child. If it's the right child, then we need to go ahead and send back the right child. Now, we indicated that what is confusing about this is this piece right here. Which is what happens when you have 2 children. Well, we said that what you need to go ahead and do when you have 2 children is you need to go ahead and go to your leftist. So min, let's say we called it left. So let's just say we call that function. And our job is to go ahead and go to the right of that leaf. So this means that if we want to go ahead and get rid of that 9, we need to go ahead and go to this 12. And we need to go ahead and go to the right. And so that's a function that we call. And then there's something that's going to be returned from that function. And what is going to be returned is going to be some kind of a value. And what is that value? That value is going to be that 9. And then once we have that value, we're going to go ahead and say, hey, leaf the value equals to value. And what that is what is the leftist node in our right subtree. We return the 9, and the 9 is going to go ahead and replace that 7. So that's what we have. And then what I need to go ahead and do is I need to go ahead and say, hey, let's go ahead and delete. And so I'm going to go ahead and issue a delete to go ahead and get rid of that 9 because that extra 9 needs to be eliminated. And where do I need to go ahead and start? Well, in this case, I'm going to go ahead and start from leaf right. So if this is my leaf, I need to go ahead and start my search from right there. And I am looking specifically to go ahead and look for this thing called value, which is that 9. And I need to go ahead and get rid of it. So that's what I need to go ahead and do. Now, you notice that this function that we're looking at, there is a return. So we are returning, let's say, null in this case. So then there is something that is being returned in this function. And exactly what is being returned. So in this case, if let's just say we want to go ahead and get rid of the 2, this is going to become null. And so I need to go ahead and return the null over here. And so the left of this is going to be pointing to null. And then what happens is when we, but we can't just go ahead and return it for this 1. We need to go ahead and continue the return. So the 3 is going to be reconnected to the 5. And the 5 is going to be reconnected to the 9. Okay? So the path that we actually traveled, it needs to go ahead and travel back up. And this very last node that we actually went ahead and messed with, it needs to go ahead and reconnect in whatever way it needs to the rest of what we want to go ahead and delete. So for this reason, what is happening is this function that we're looking at the end of the day, this whole entire function, there are times when we actually go ahead and return right in the middle. But then there are times when we actually need to go ahead and just return leaf. Okay, so what is happening is the leaf that we are on. So let's just say if we're on this, we need to go ahead and reconnect. So send back whatever the address of the leaf is back to where we came from, so that we could actually go ahead and reconnect the left of this to this thing right here. And so notice the calls that we're actually making, they came from here. They came from here. So this means that we have a leaf left. This means that we have a leaf right. So we actually go and capture the return values so that we can go and reconnect the tree as we go ahead and go back up. And and then what about this delete right here? Well, when we are actually deleting here, what is going on with this? So here I have this 9, okay? And what am I doing? So we're going to go ahead and call the delete function from here. And so it's going to go ahead and delete and do something. And so it's going to go ahead and just resolve whatever it's going to go ahead and do in the normal way. And then at some point, what we have is this node right here, okay, which is this leaf right. And what do we need to go ahead and connect it to? We need to go ahead and connect it to this 9. So leaf right needs to be connected to this one right here. So then this means that we have leaf right equals to that. So you notice that we are actually making all these connections. And so this would be an example of a non-tail recursive method. So if we're making all these recursive calls, one after another, well, it looks like there's all this reconnecting that we're doing on the way back. And if we're doing all these reconnecting, then this would be non-tail. And how do we know that we're doing a reconnecting? Because when we call the function, we actually assign it to something, which means that after it's done with all the recursive calls, it's going to go ahead and come back and reconnect to something. Same thing is true with this. It's going to go ahead and reconnect. It's going to go ahead and reconnect. So we are expecting for something to be returned, and it's going to be assigned to something as we go ahead and move up the hierarchy of calls that we've actually made. So I'm hoping that this makes sense with regards to how this deletion is working for us. So I'd like to go ahead and just maybe pause here for a moment and see if anyone has any questions with regards to how this needs to be done. The fact that you go ahead and just continue to search, and at some point the search will actually go ahead and give you nothing. At some point, if you don't find it. And so that's where you actually go ahead and get a leaf that is none. And so when you go to get a leaf that is none, and then you return the null, which means the null is what you have. So at some point, you go ahead and just do like a left, left, left. And so let's just say when you go ahead and you're at 2, let's just say you want to go ahead and delete a 1. So 1 is less than the 2. And so you go to your left. And when you go to the left of this, you come across a null. So when you come across a null, you're just going to go ahead and return a null. The null is going to be assigned to the left of this 2, which is already a null. And then we're going to go ahead and return. So there's that. We return the null. And so then now that we are on 2, we're going to go ahead and return leaf, which is that 2. It's going to be connected to the 3. We're going to go ahead and return the 3. It's going to be connected to the 5. So that's how that works. Now, there's a question here. It seems a little odd to have delete return something. Well, actually, it's not odd, because if you go ahead and take a look at this piece right here, let me just see here. I want to go ahead and make this a little brighter. Okay, so if you have 7, and you have 5, and you have 3, okay? Let's just say that you want to go ahead and get rid of this 3. If you want to get rid of this 3, well, you get rid of it, and then you go ahead and return. And what are you returning? You're returning a null. Now, when you return the null, so at this point, notice that the left of 5 is actually connected to the 3. When you return the null, you go back to where you came from. And where do you come from? You come from this leaf, and its left needs to now be assigned to null. If you don't assign it to null, this will still, the left of 5 that you're looking at. So this is the node that we have. Okay, 5 right there. The left of this node 5 is still pointing to some address. Although we have completely eliminated that, it still thinks that that address lives. We need to go ahead and make sure that this null that is returning is actually placed right there. Or consider what happens if you go ahead and say that you want to go ahead and get rid of this 5 right here. So let's just say that you go ahead and do a search and you get to this point. So leaf is right there. And you have one child. So then what you need to go ahead and do is at this point right here, you need to go ahead and do a return. And what do you need to return? You need to return what? In this case, leaf left. Yes? So whatever this thing is pointing to, you need to go ahead and return it. So when you return it, where does it go? Take that 3 and connect it back up to that 7. And so that's what needs to go ahead and return. And so this means that I've left this empty right here. When you have no children, or when you have the one child, at this point, you're going to go ahead and do these returnings in here. You're going to go ahead and have these returns in here. If you have no children, okay, that we're dealing with, then at this point you're going to go ahead and delete the node. And return null. Well, in this case, you're going to go ahead and delete the node because this is the time when you actually have one child. And then you need to go ahead and return either leaf left or leaf right. So this is the problem that you're facing with regards to a node that has one child, which is this one right here. If you have one child, you need to go ahead and return the left in this case. But of course, the child could be on the other side, which means you would need to go ahead and return the right. So you need to go ahead and just have this if statement, which knows whether which side actually has a null. And you need to go ahead and return the opposite side. Now, if you're deleting 3, what does the function return when going back to 5? Okay, so I think I just answered that. Let me go ahead and just make this a little neater. Okay, so if you have 7, if you have 5, if you have 3, if you're deleting 3, okay, what does the function return back going to 5? Well, so this is the case of the fact that this 3, which is where you're sitting at, because you have to go ahead and find the 3 first, okay? And this is the case where you're dealing with the no children. You need to go ahead and first delete the node, as I indicated. And we know, it's kind of like a free node, or if you're using C, or you can just go ahead and use delete, and then the actual, so we delete leaf, okay? And then you need to go ahead and return null. That's what you would return. So after you get rid of this, you return null. Now, exactly where does that go? Well, remember that the way that you actually went ahead and landed on that 3 is because you had made a decision at an earlier point that when you were here, for example, that 3 is less than 5, so you need to go ahead and move to your left. So you're going to go ahead and go back to the call that actually prompted you to go ahead and move down here. Exactly where is that? Well, take a look at this. If key is less than leaf key, then you need to go ahead and move to your left, which means that at this point, this function is going to go ahead and return back that null. And so leaf left now is going to be assigned to null, which means if we have come back to here, and that's our leaf now, the left of this is going to go ahead and point to that null. That's what we did. What other questions do you have for me? So I'm hoping that you're seeing why we need to go ahead and return something. And you can also go ahead and see that this beginning piece that we're looking at, this pertains to the actual searching, where we either find nothing or we are on the way to actually finding something. And once we actually go ahead and find something, we make a decision. No child, one child, two children. And then when we go ahead and send back whatever it is that we're sending back, it's actually going back to the calls. And the calls are right here. And so this is where we actually go ahead and make the connection. Now, let's go ahead and see here. We return null to 5 left. How about 7 left? Okay, so that's great. Now, if you remember, I indicated that what is going on is when you go ahead and take a look at this thing, this whole entire function that we're looking at. So let's say when you're looking at this condition, this else if condition, well, inside of here, we are not returning anything. Inside of here, we're not returning anything. So there are places in which we are not returning anything. But this is a function that has a return value. In this case, we are returning a null. In the case of no children, we were returning a null. So we always have to go ahead and return something. So at the very, very bottom of this, we're going to go ahead and say that this entire function that we're looking at the very, very end of it, it's going to go ahead and return leaf. Now, why does it return leaf? So keep in mind that this is how we actually went ahead and traveled. My first recursive call, I started from here. That's what my leaf was. And then I decided I want to go ahead and get rid of 3, so I went to my left. So when I go to my left, I go ahead and call a function, delete, and I say leaf left. So then on the next recursive call, this becomes my leaf. And then I check 3. 3 is less than 5. So I move on over to leaf left. So I make another call while I'm here to leaf left. So I land right here. When I land right here, I recognize that, you know what? I have arrived at the place where I need to. I go ahead and get rid of this, and I go ahead and return a null. And then this is the path that I traveled. So I need to go ahead and travel back that same path, which means that I go ahead and go back to where I came from. The null is going to go ahead and come back to here. Well, exactly what did I do here that caused me to land right there? Well, it was the following call. Delete, leaf, left, key. And what am I going to go ahead and do? I'm going to go ahead and assign that to what? Leaf, left. Which means that if 5 is my leaf, its left is going to go ahead and contain the null that we just returned. So this means that this 5 that I'm looking at, its left is going to go ahead and have a null. Then, after I'm done with this, what am I doing? I'm returning leaf. What is leaf? Is 5. So I'm going to go ahead and return back 5. So return leaf, which is the address of that node. I'm just going to go ahead and say 5 at this point. And so you'll know that it's just the address of that node. Well, so it's going to go ahead and go back. To go back to where it actually came from. Where did it come from? Well, when we were here, we actually went ahead and made a call. And what was the call? Delete, leaf, left, key. That was the call that we had made. So it was because of this call that we actually went over to 5. And now, that's where we came. So what is coming back to us is the address of the 5. And what are we doing? we're going to go ahead and set that to leaf left. So this 7 that we're looking at, its left is going to go ahead and point to that 5. Now, one could actually go ahead and say that, you know what, 7 is already connected to the 5. Why are we doing this? Well, we're just overriding it, and we are just reconnecting it. And the reason why we do this is because I can't say that as I'm returning for this one return, I want to return something, but for the other returns, I don't want to return anything. You have to have this consistency. If you're returning, you have to return all the time. And so in this case, I'm going to go ahead and return the null, which I need to. I reconnected, and so I return the very same thing that is connected to 5, which is the address of the very leaf that I'm on. So, let's see. So after the null is returned to 5, it then sends 5 nodes back to 7. That's exactly it. That's exactly as you've indicated. We return the null to that call and return the 5 to that call. That's precisely it. And in the code that we talked about, these are the places where we actually go and move to the left or move to the right. And so the answers are coming back here, and then this is where the connections are being done. So there's no need to incorporate so there's no need, okay, so let me just see here. So there's no need to incorporate the delete statement if the delete node is just floating there. Okay, now let's go ahead and make a distinction between our function that we have just created, which we're calling delete, which takes in 2 arguments, okay, one of which is the address, the other one is the key, and the actual keyword that we have in C++, which is delete, or in C, which is free. So let's go ahead and find out. So these are not the same. So when you're actually dealing with wanting to go ahead and delete these nodes, so when we have a 7 here, a 5 here, and a 3 here, when you get to a 3 and you want to go ahead and delete it, this is a node, and this node should not be hanging around. So you need to go ahead and get rid of this node. And for that, you need to go ahead and use the C++ keyword delete to get rid of it. There's no getting away from it. This has nothing to do with our del function that takes 2 arguments. Or, if you come here, you need to go ahead and get rid of that node. There is no buts about it. So you need to go ahead and use the delete or the free, however you actually went ahead and created this node, which means that this needs to be severed, that needs to be reconnected like this, but this node should not exist. So this is something that needs to be done. With regards to no children or 1 child, there is this deletion that's happening of the actual node. Now, in the case of 2 children, the immediate child that the node that you want to go ahead and deal with, that node does not get deleted. Okay? However, when you go ahead and we said, like for example, there is a 12 here, and then there is a 9 here, and let's say there's, I don't know, an 11 here, okay, or something. So in this case, when you go ahead and take that 9 and you replace it right there, we don't delete that node. But then we make a subsequent call that says, why don't you go ahead and delete that 9? In that case, we go ahead and delete, which is issue these keywords from C++ to get rid of it and reconnect the 11 to the 12. So I hope that answers your question. You still have to go ahead and delete the node. If not, you will get a memory leak. That's exactly it. So does anyone else have any questions about why we need to go ahead and return? The fact that we need to go ahead and delete? and how this delete function stuff actually works. Any questions on this? So, if you don't have any questions, I'd like to go ahead and just introduce you to the next assignment that you're going to be working on. And this assignment is really quite simple. So you have this input file, and this input file contains a bunch of things. So look at that. This is the stuff that it actually contains. Let me go ahead and just finish up this conversation, and then we'll get back to the question that's actually coming up. So what we have here is we have all of this. So when you actually go ahead and have a 1, 2, 3, it's going to go ahead and do an insert. So all of these are equivalent to inserts. So you go ahead and put a 1 here, and then we have a 2, and then we have a 3, and everything is going on the right, okay, as we can tell. And then we come across this line. It says delete 3. So now you need to actually go ahead and call upon the delete function to go ahead and get rid of this 3. Then we actually go ahead and insert a 5. Then we insert a 6. And then it says delete a 9. And so we look. And do we find a 9? No, we don't find a 9. And so let's go ahead and find out what actually happens with the 9. So if the number is not found, insert the node. So at this point, since there is no 9, we're not going to go ahead and give up and say, you know what, that's it. We're going to go ahead and insert the 9 here. So that's how that works. So that is up to this part. And you can be sure that there are no duplicates in this tree that we have. So you don't have to worry about what you were doing in your previous assignment, which is a bunch of inserts. Now, let's go ahead and just see if we can answer some of the questions that you have here. In the assignment, we have a linked list. How would we deal with that delete? So once again, what is going on is, in this case, we are going to go ahead and eliminate the linked list that we had in our insert assignment. So that is no longer the case. This is just a simple assignment where we actually go ahead and do these inserting into a tree. There are not any duplicates, and we just then go ahead and delete. Now, just in case you did want to go ahead and just see, okay, so what happens if you were looking at the last assignment in which, let's just say, if you remember in the last assignment, we said that we're going to go ahead and do an insert, and our nodes are these special nodes where we have the left, we have the right, we have the actual key, and then we have here this head that is going to go ahead and point to these other nodes. So let's just imagine that, this is a node that we actually, let's just say that, for example, let's just say that's the 6. And let's just say that we want to go ahead and delete the 6. Well, at this point, when we want to go ahead and delete the 6, notice that there's only one child. So we need to go ahead and actually remove this from memory. So not only do we need to go ahead and remove this from memory, but we also need to go ahead and remove these things from memory as well. And so what this means is that we need to go ahead and, before we go ahead and get rid of this one, we need to first come here and we need to go ahead and traverse through this list one by one, and we need to go ahead and get rid of it. Get rid of this one. Get rid of this. And at some point, we get rid of this entire set that we have. So that requires a loop that we go through. After we've cleaned up the linked list, then we come over here and we get rid of this one as well. So it's certainly a lengthier process that we actually have to go through. So for the current homework, how will we clean up the entire tree? Do you recommend we start at the leaves, perhaps the parents before the leaves? I meant to type this sooner. Okay, so I think the question has been answered then, because once again, in this assignment, we don't actually have to worry about the duplicates, and it's only the single node. But as I indicated, if we did have the last assignment, you would need to go ahead and clean all these up one by one as well by going through a list. Now, that's one of the nice things about Java. With Java, you wouldn't actually have to go ahead and do that. With Java, if you actually go ahead and just take this head and you go ahead and just say, you know what, I'm not pointing to anything. Well, then this whole thing begins to go ahead and fall apart like a house of cards. And all of this will actually be removed for you automatically by Java. And also with this one as well, in Java, you wouldn't need to go ahead and delete that. You just need to go ahead and take the previous node that it's connecting to and take its leaf left or leaf right or whichever one and just set it to null. And Java will actually go ahead and take care of the cleanup for you. So wait, would we take the input as chars or ints? Well, in this case, as you can tell, what we have here is so you're going to go ahead and read this input. And you notice that there is a space, yes? So what will occur is you want to go ahead and read this as an array of chars. Or you can go ahead and read this as a string. So that's a string, that's another string, that's another string, that's a string, that's a string as well. And so whenever you actually come across this delete, then you need to go ahead and do another read. And so when you actually go ahead and read this, and now this is sitting in a variable of type string, then you need to actually go ahead and, so let's just say, when you're reading the stuff, it's going into a variable called input, which is of type string, okay? Well, then you can actually go ahead and say, if input equals to delete, okay? Then at this point, you need to go ahead and read again so that you can go ahead and find out what that thing is. And now that you've understood what that thing is, you're ready to go ahead and act. You're ready to go ahead and do a search and a delete. So you basically go ahead and call the delete function that we have. Now, if you don't want to go ahead and read the input as a string and you want to go ahead and read it as a char array, you certainly could. But it has to be a char array, because notice when you're actually reading this, well, that's not just a character. It's an entire word. So you need to go ahead and read that entire thing. And so that's what's involved with that. But the only reason why I'm saying that you could actually go ahead and read it as a string is so that when you want to go ahead and do a compare to find out what you have just read, you actually just go ahead and use the double equal sign. If you do not use the string data type and you go ahead and use a char array instead, then you would actually have to go ahead and use the strcmp function. And I think I've just indicated that the strcmp function, the way that it works is you go ahead and feed into it one string, you go ahead and feed into it another string, and this function will actually go ahead and returns to you a positive number, a negative number, or a 0. If it's a positive number, this means that is bigger than that. If it's a negative number, this means that this information that you have is bigger than that alphabetically. And if it's equal to 0, then this means that they are the same. So what you want to go ahead and do is you want to go ahead and compare your input in here against the string delete. And you want to go ahead and say, well, does it equal to 0? And if they're identical, then this means that this is where you need to go ahead and read another item from the actual file, and then you're ready to go ahead and do the delete. To clarify, this is the assignment we are actually doing, not the insert. Let's see here. And for the duplicate names on char array nodes. Yeah, so you're still doing that, insert search assignment, so that doesn't go anywhere. But for this assignment, okay, what you will do is you will actually go ahead and do a very simple insert, okay? It's like the one that I've provided to you in the notes. So that's the algorithm that you would use, in that you don't deal with duplicates. And also it's an actual BSD tree. You're not actually reversing, what goes on the left, what's going on the right. So with regards to this assignment, it's an actual BSD. The small stuff goes on the left and the big stuff goes on the right. So let me just see here. So insert is still undated and it's locked. Okay, so I'll go ahead and modify that to make sure that it's actually all good. So we'll fix that. All right. Any other questions on this? So, of course, this assignment that we're looking at right now, it actually has a few other items as well, and we have not talked about this stuff right here. So at this point, I can't go ahead and give you a due date because there's more stuff that we need to go ahead and deal with. So we don't have a due date for this, but on the other one, the due date on that, we'll actually go ahead and make it like, I don't know. I guess we could go ahead and make it Sunday. That's all. Okay. Yeah. It'll be due this Sunday night. The last assignment. Yes. Yeah. All right. So I guess we have this, and so let's go ahead and now, if we are good with the search, the insert, and the delete with all that's been discussed, then we are ready to go ahead and talk about something else. So it's going to go ahead and pertain to trees. And so let's find out what is happening here. So, we have this little bird. It's not a woodpecker, but I think we've heard this bird before. It just doesn't let go. So that's what the noise is all about. So we have an uninvited guest. All right, so let's see what is going on. Now, this next topic that I want to go ahead and discuss with you pertains to the following. Let's just say that we have this tree. 7, 5, 9, 3. Let's say we have 6. Now, what if you want to go ahead and process? Well, let's not process. Let's say, what happens if you want to go ahead and print the contents of this tree? So, you can actually go ahead and print the contents of this tree in many, many different ways, okay? So you could actually go ahead and just, do the 7 and the 5 and the 9 and the 3 and the 6. That's one way that you could go ahead and do it. But that's not the only way. You could actually go ahead and do it like 7, 5, 3, 6, 9. Or you could actually go ahead and say 3, 6, 5, 9, 7, okay? So there are all these different ways that we could actually go ahead and display the information. Now, we haven't really talked about the purpose behind wanting to go ahead and read this tree in these various ways. And so let's not worry about the reasoning behind it. Let's go ahead and find out what some of these popular traversal methods are to go ahead and read this. Now, one thing that I want to go ahead and indicate here is that when you're actually doing these traversals, there is the in-depth traversals that you could actually go ahead and do, which means that you're going to go ahead and go deep. Okay, and that is how you're going to go ahead and do it. And there is, so the depth level, okay, so the depth, and then there's another one which is breadth, which means that you want to go ahead and start looking at this level, and you want to go ahead and look at that level, and you want to go ahead and look at that level. So one actually is kind of expansive, okay, and then the other one just sort of drills in. And that's what we want to go ahead and look at. So let's go ahead and come over here and find out what is going on. So depth first, traversal. Okay. Now, once again, there are these various ways. So one of them is a pre-order. Another one is in order, and the other one is post-order. So, notice what it says. It says, visit the route, traverse the left, then traverse the right. Now, this other one, it says, in order, traverse the left, visit the root, and traverse the right. Now, and then this one right here, traverse the left, the right, and the root. Now, this is post order. Now, when you're looking at the roots, okay, in essence, you can go ahead and think of it as the node that we are on. So, let's go ahead and see what this all means. Now, to go ahead and just make some sense of this so that we don't have to go ahead and memorize all this, it would be nice if we have some kind of a way to keep this all in mind without having to go ahead and rely on so many words. So for this one, I want to go ahead and say that we'd go ahead and do a V, L, R. So apparently in all of these cases, the left comes before the R, the right. Okay, so keep that in mind. Now the pre means before, and whether it's pre or in or post, that is pertaining to the V. And in the V, when we're visiting it, we could actually go ahead and process the node. And processing the node means you could go ahead and display it. You could go ahead and take the items that are in that node and you can play around with it and do whatever you want. But this V is actually us wanting to go ahead and do something with that node, process it in some way, shape, or form. And this left, we're moving to the left or we're moving to the right. So there's that, and that's pre before. Now, the in order, you can think of it as kind of like when you go ahead and do the 1 plus 2. You remember the infix notation where the operator was in the middle? Well, this is no different. You have the left, you have the visit, and then you have the R. So this means that whatever you want to go ahead and do in terms of processing that node, you go ahead and do it after you've gone to the left-hand side. And then the post means after, which means that you go ahead and do the L, the R, and then you go ahead and do the V. And you can just, think about the postfix. You remember we had the 1, 2 plus, and whether we have the infix or the postfix, it's referring to the operators. Where does the operator go? Does it go in the middle? Does it go after? Or there's a prefix, does it go before? This is no different. Whatever we are doing with the node, do we do it in the beginning? Do we go ahead and do it somewhere in the middle? Or do we do it at the very, very end? So that's what we have. Now, in order to go ahead and take a tree and start traversing through it, as you all know, we could actually go ahead and approach this from a non-recursive way, or we could actually go ahead and do it from a recursive way. So this would be an example of, us doing it non-recursively. Now, I could go ahead and discuss this, but let's go ahead and skip it. Let's not worry about it. But now take a look at what is going on here. I have decided to go ahead and do things recursively. Now, this right now should actually go ahead and convince you as to why you would want to go ahead and approach, some of the problems in this recursive way. Because if you remember, we said, like for example, with regards to the pre-order, it is V, L, R. Now look at that. Print, go to the left, go to the right. Or the in order, we said what? It's L, V, R. Look at that. We go to the left, we print, or we go to the right. Now, notice that when you go ahead and do these things recursively, how nice and how simple they look. It's kind of like the factorial function that we talked about, or how the Fibonacci series. It looks very much like the original formula. But then you go ahead and compare it to the non-recursive way. This looks nothing like the LVR or the VLR or any of that stuff. It looks very complicated. And it is for this reason why some folks would actually want to go ahead and stay away from the non-recursive way, because it doesn't look very intuitive. Now, the question that actually comes up is, well, exactly what does VLR or LVR mean? Exactly how do we traverse through the tree? So let's go ahead and just find out. Now, here I go ahead and show you all the different calls that we have so that you can see what the layout begins to look like. And in each of these boxes, we're looking at a pre-order, okay, and I'm just calling it PO. and this is on the leaf that's actually being processed. And all that we're doing is we're going to go ahead and, in terms of processing, just display the information. That's the only thing that we're going to go ahead and do. Now, imagine as if this is the tree that we have, okay? And if that's not making any sense to you, it's really just 7, then 3, then 2, and then 6, okay? So hopefully you can see, this makeup is really equivalent to that. Now, a pre-order. So we're going to go ahead and start from right here. And so it says, why don't you go ahead and print the very node that you're on? And then it says, why don't you go ahead and move to your left? So when I go ahead and move to my left, this means I'm sitting right there. And then when I'm sitting right there, it says, why don't you go ahead and process that? So we have the 7 we've displayed, the 3 that now we're displaying, and then this thing says, why don't you go ahead and move to your left? So then I go to my left. So I'm sitting right there. And then it says, why don't you go ahead and display what you have, which is that 2. And then it says, go to the left. But now when I go to the left, I have nothing. Now take a look at the actual algorithm itself. The algorithm says that when you actually go ahead and pass in whatever you have, if it's not pointing to anything, then skip this. Don't do any of that stuff. So what this means is that this null that we have, when we call it, we do nothing. We just come back. Well, at this point then, we need to go ahead and process what is happening on the right. Well, on the right of this, there is nothing. So we just come back. So now this function is over and done with. And so I come back here. When I come back here, at this point, where have I landed? I've landed on this one right here. And I've processed the left-hand side, so I'm now ready to go ahead and deal with the right-hand side, which is that call right there. And when I go to that call, well, I come over here, there's the call, and so I go ahead and process the 6. And then with that 6, I'm going to go ahead and process its left-hand side. Well, there's nothing in there. I come back. I process then the right-hand side. Well, there's nothing in there, so I come back. And so then, at this point, I can say I'm done with that call. And I come over here, and I can say I am done with this call. And I come over here, and so this means that everything on this side has been processed. And so I'm ready to go ahead and do this. So this means that I'm sitting right there, and this is not pointing to anything, so I go ahead and process that, and so I'm done. So this is what I get. 7, 7, 3, 2, and 6. Now, what happens when you go ahead and do it with the in order? So, the same thing, doing it with in order. So, if you remember, once again, we have 7, 3, 2, 6, and this is in order, which means it's sitting in the middle. So we have L, V, R. So that V is actually sitting in the middle. Okay, so how does that work? This says, at this point, you are here, but then don't process it, go to the left. So then I come over here. Well, then when we are here, it says don't process that node that you're on, go to your left. When I go to my left, it says don't process that, go to your left. But when I go to my left, there is nothing, it's a null. So then I come back. Now when I come back, I'm going to go ahead and visit, which means I'm going to go ahead and deal with the 2. Then after I go ahead and deal with the 2, then I need to go to the right. But there's nothing going on with the right, so I'm done. So then this means I'm just done with that. Then I go back to where I came from. Well, this is where I come from. So I just moved to my left, so I need to go ahead and visit that node now. 3. And now I need to go ahead and move to my right. I move to my right. But then I don't need to process that yet. I need to go ahead and move to my left. There's nothing to my left, so then I come back and I go ahead and visit. Then I go ahead and move to my right, but there's nothing, so I'm done with that. So then I come back here, and so I'm done with the 3. And then I come back over here. And so the left part of 7 is done, so I'm ready to go ahead and visit 7. And then I go ahead and process the right, but there's nothing on the right. So we're done. And now let's go ahead and do the post order. Now the post order is 7, 3, 2, 6. Remember, post order is what? L, R, V. So you do the left, you do the right, and then you do the visit. So I come over here. L, R, V. So I'm going to go ahead and just do that. L, R, V. I'm going to go ahead and do that. L, R, V. Nothing is happening on the left-hand side. Nothing is happening on the right-hand side. I'm ready to go ahead and visit the 2. So then I go back here. So the left is all done. All of that is done. I'm ready to go ahead and do the right. Well, what is happening on the right of this? I come over here. So we have L, R, V. Nothing happening on the left of 6. Nothing happening on the right of 6. So then I'm ready to go ahead and do that. So then at this point, I'm done with all of that. So I come back here. Well, this means I'm done with the right. So I'm dealing with the visit. So now I can go ahead and deal with the 3. So then at this point, I'm done with all of that. So I go back. It says deal with the right. There's nothing going on with the right. So I'm done with that. I'm done with that. And I go ahead and do the visit, which means I have that 7. So you notice how we've done all of that. So let me just go ahead and do something here. Okay, I'd like you to go ahead and do the following here for just a moment. I'd like you to go ahead and take this and just spend a small little moment and come up with the pre, the in, and the post. Let's see what you come up with. The pre, the in, and the post. And the same thing is true with this, the pre, the in, and the post. Why don't you guys go ahead and do it for these 3, and let's see what you come up with. And I'm going to go ahead and give you, it's 4:05. Well, let's go ahead and just give you another 2 minutes, okay? So let's just go ahead and give you 2 minutes to go ahead and do all this stuff. Maybe 2 minutes is not enough time. Well, let's go ahead and just give you 2 minutes to go ahead and do this first one, okay? And then we'll go ahead and just do these things together. So why don't you go ahead and just focus on this first one, see what you come up with. And you can write this down on a piece of paper. All right. Well, it looks like that is 2 minutes. If anyone has any objections, that is not 2 minutes, please speak your piece right now. Otherwise, I'm going to go ahead and try to solve this. Going once, twice. All right, we are ready. Okay, so let's go ahead and find out what is going on with the pre. Okay, so just so that we don't forget, pre is VL, post is LRV. Okay, so that's what we have. So in this case, we're going to go ahead and do the pre. So this means we have, we're going to go ahead and visit the 7, and then we're going to go ahead and move to our left. visit the 3, then move to our left, visit the 2, and then at this point, so just so that actually we don't get lost here. So remember that we have V, L, R. So we just did the visit and we moved to the left. V, L, R. We did the visit and we moved to the left. And then we come over here, V, L, R. We did the visit, we did the left, we did the right. And so then this means we go back to where we came from, which is right there. So this means we are done with the left. And now we are ready to go and do the right. So this means that we come over here. V, L, R. So then we are ready for the 6. And then there's nothing on the left, there's nothing on the right. So we're done with this entire thing. And so then we come back here and we're done with that. And so this means we are done with the left. And so then let's go ahead and move on to the right. Well, on the right, we actually come over here. We have V, L, R. So then we have the 20 that we're going to go ahead and do. Then we come back here to the left. V, L, R. We're going to go ahead and deal with the 9. And there's nothing on the left of 9, nothing on the right of 9. So then this means we go back to where we came from, which is right there. So the left is done. Now let's go ahead and do the right. On the right, we have V, L, R. So we go ahead and visit the 22. There's nothing on the left, nothing on the right, so we're done with that. So we came back from here, so that's all done, so we're done with that. And then we go back to here. We just finished up the right, so we're done with that. And so this is what we actually go and see for the pre. Now let's go ahead and just do the in. It's L, V, R. So let's move to our left. L, V, R. Let's move to our left. L, V, R. Well, there's nothing on the left. Let's go ahead and visit, which means we get the 2. And then that's all done. There's nothing on the right, so we're done. So this means now we go back to where we came from, which is that left. So there's that. We visit, which means we have the 3. And then we go to the right, which means we have L, V, R. So there's nothing on the left. So then we process that. And then there's nothing on the right. We're done with that. Which means we go back to where we came from, which is right there. So we're done with that. So this means that now we go back to where we came from, which is right there. We're done with that. We visit, which means we get a 7. And now we go to the right. So we have L, V, R. And so we are going to go ahead and go to our left. And so we have L, V, R, which means there's nothing on the left. We visit that, so we get a 9. And then there's nothing on the right, so we're done with that. And so this means the left is done, so let's go ahead and visit the 20. So we're done with that. Then let's go to the right, which means we have L, V, R. So nothing on the left. Then we go ahead and do the 22. And then nothing on the right, so we're done with that. So this means we go back up. We're done with the right. We go back this way. There's that. And so there is the infix. Or the in order, actually, I should say. And so let's go ahead and just do one more, which pertains to the post order. Okay. So this is L, R, V. So we need to go ahead and move to the left. L, R, V. Move to the left. L, R, V. Nothing on the left, nothing on the right. And so let's go ahead and visit it. So we get a 2. And so, by the way, this is once again the post order. And so then we are done with that. And so we are done with the left. And so now we need to go ahead and deal with the right. So I go to the right, which is right there. And so we have L, R, V. There's nothing on the left, nothing on the right. And so we just visit that. So we get a 6. So we're done with that. Now let's go to the right. And on the right, we go L, R, V. So I need to go ahead and move to the left. So we have L, R, V. Well, there's nothing on the left of this 9, nothing on the right of that 9. And so we just go ahead and display the 9. So we're done with that. And so then this means we are done with the left. Now let's go ahead and do the right. We have L, R, V. Nothing on the left, nothing on the right. And so we just go ahead and deal with the 22. We're done with that. And so then this means the right is done. And so we're going to go ahead and visit that. So we have 20. And then, so we're done with all that. We go back over here. The right is done. And so we're going to go ahead and visit that, which means we actually go ahead and just get the 7. Does anyone have any questions about what we have done here? Okay. Let me go ahead and just do this one more, okay? And then we'll go ahead and call it quits, okay? So we're getting close to that. So this one looks a little odd, okay? And so let's go ahead and just do the in order here, okay? And see what that begins to look like. So the node that we are on needs to go ahead and get processed. So this means we are going to go ahead and process the 7. Then we process the 3. We process the 2. Then we process the 1. We process the 0. And notice that right after we process, we go to our left. Now, so then we go back up here. And now we need to go and process something on the right, but there's nothing on the right. So we go back up here. We need to go and process something on the right, but there's nothing, so we're done. We go back up here. Well, we need to go and process something on the right, so we go over here. And the very first thing we do is we go and process what we're looking at, which is the 6. And so at this point, that's all done. So then we are over here. We've already processed the 7, okay, because it's, once again, VLR, okay. And so then we come over here. We're going to go ahead and process the 20. And then we come over here to 9. We're going to go ahead and process the 9. So this one is all done. Then this one, we went ahead and already, well, at this point, we're not completely done because we did the visit, which is the 20. Then we did the left. Now we're ready for the right. So we are going to go ahead and come over here, 22. We're going to go ahead and process that. There's nothing on the left. So then let's go over to 24. Let's go ahead and process that. Nothing on the left. Let's go to the right. And so we go ahead and process that. And then we just go ahead and travel all the way to the top until we're done. So that's what we actually go ahead and get in that case. Let's go ahead and do another one. Now in this one, we're going to go ahead and do the in order. And the in order is left VR. Okay, so the node that you're on, let's just go ahead and wait. We don't process it quite yet. So we have LVR, 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 LVR. So we process this one right here first. And then we come over here. We're going to go ahead and visit that. And then there's nothing on the right-hand side. So we're going to go ahead and come back here, visit that too. There's nothing sitting on the right. So we come back here, we visit that. Then we go to the right. Well, this has got an LVR, nothing on the left. We process that, nothing on the right. So we're done with that. And so we come over here. We're done. We have processed the left. Now we're ready to go ahead and visit. And now we move to the right. LVR. We process this one. So we deal with the 9, and so we're done with that. Process that. We are ready to go to process the 20. And so we go ahead and do an LVR, which means there's nothing on the left. And so we process the 22. And so we've done that. We move to the right. And so we have LVR, nothing on the left. So we go ahead and process the 24. We move to the right, LVR. We process the 29. And then we just start climbing back up. And so that's what we have. And, oh, okay, you were doing pre earlier. Yes, that is correct. And so let's go ahead and do the post. So we're going to go ahead and do the post. And what is the post? LRV. Okay. So this one is LRV, LRV, LRV. We're just continually moving to our left, LRV. Then we go ahead and deal with that 0. That's the first thing. Then I need to go ahead and deal with the stuff that is sitting on my right. There's nothing there. So then I'm ready to go ahead and process that. So there's that. Then I have done that. Then I need to go ahead and move to my right. There's nothing to the right of 2. So then I'm ready to go ahead and visit it, 2. So I'm done with that. So I'm done with the left. Let's go ahead and move to the right. We have LRV, nothing to the left or the right of 6. So we just go ahead and deal with that. That's all done. That right is done. We're ready to go ahead and visit the 3. So this is all done. Left is done. We move to the right. So we have LRV and we have LRV here. So we're going to go ahead and process the 9. That's all done. And so this means this is all done. We need to go ahead and move to the right, which means we have LRV. Nothing is happening on the left-hand side. So we go ahead and do the right. And so we come over here, LRV. Nothing is happening on the left. And we go to the right. And then we go over here. Nothing is happening on the left, on the right. So we visit. So we get 29. And so now that we're done with that, this means we're done with the right of that. We are visiting this. So this becomes 24. This means we go back up to where we came from, which is right there. I'm done with that, so I go ahead and visit that, 22. This means I go back up to where I came from, which is right there. I get rid of the R, so then I'm ready to go ahead and visit that. We have 20. Then I come over here, and I get rid of the right, and so then I'm ready to go and visit that, and so we have the cell. And so, ladies and gentlemen, that is what we have. So, at this point, I'm going to go ahead and stop and see if you have any questions for me on any of the stuff that we have discussed. For a list of numbers, we want to traverse it in order, then why, when would we need the other ones? Well, so you understand that when we actually go ahead and do it in order, if we're looking at a BSD tree, the information is going to be sorted. Okay, that's the one thing that we came to find out. But the question that's coming up is why would we need to go ahead and do it in pre-order, or why would we need to go ahead and do it in post-order? And unfortunately, it is too early to be asking that question because we haven't gotten into the need as to why we actually go ahead and do a pre or a post. So you'll have to go ahead and wait for that until we go ahead and discuss it. So would it be VLR for pre-order and then for in-order it's LVR? That would be correct. Yes. Any other questions? All right. Well, it looks like we don't have any other questions. Then with that in mind, I'm going to go ahead and bid you guys farewell. So at this point, I can only say that, well, just be careful because apparently things are just happening in California, and the number of cases are, increasing. So wash your hands. Don't talk to anybody. Don't talk to family members. Don't even talk to yourself. And I think you'll be in a safe place. And I guess aside from that, hopefully everything will go well, and then we'll meet with one another in a couple of days. So I will go ahead and change the due date on the one assignment, and that's really pretty much it. So the assignment open today has an open deadline. That is correct. It has an open deadline at this point, because we are not completely done discussing everything that we need to talk about. By the way, I've noticed that, when I go ahead and take a look at this chat window, we only have like 4 or 5 people who ask questions, and everybody else sort of sits behind. So that's just not right. I guess this is true with any group. You have a bunch of folks, who kind of guide and lead, and they just sort of create the pathway for everyone else. Everyone else just is just there, just like class. That's exactly it. But I think we need to go ahead and take it just beyond just like class. It's just like life. I think we notice that there are some people in life who are they just lead no matter where they go. And I have to go ahead and say that in my own family, um, well, actually, in my sort of extended family, I see this, like with my sister. My sister, it doesn't really matter what environment she's in. She just shines and she just guides and she asks, and then she's the one who's guiding and leading. Whereas I just sort of sit back and I just watch and I don't engage. I'm kind of like, most of you guys. So I think, as you say, it's just how we are, and it just leaks into all these other environments as well. But don't be shy. And the nice thing about this environment, it's anonymous. Because I don't really know who Ben is. I don't really know who Jay Cuz is, okay? I don't know who any of these folks are. And I don't think anybody does either, anybody else in the class. So really, we're all anonymous. So you guys can go ahead and say whatever you want. Well, of course, as long as it's all good. Yeah, we got to experience some sort of leadership. And this is the place to go ahead and do it. Because you can go ahead and exercise that leadership and ask all kinds of questions, and you'll know that you'll be just fine. So this is the wonderful thing about anonymity. You can go ahead and do whatever you want, and you'll get away with it. And nobody can go ahead and say or do anything, because nobody knows who they're dealing with. All right. Well, ladies and gentlemen, I think at this point then we can go ahead and say goodbye to one another. Take good care of yourself, and we will see you soon. Or talk to you soon, I should say. All right.